Hey everyone, as I promised, we are back very quickly, and now we are continuing our Node.js Global Summit powered by Geekle. We are on junior track, and now we are going forward to Gadi. I'm happy to announce the experienced software developer that in the past few years was working with Node.js, and he's an expert in the areas of microservices, architecture and design, big data, and high-scale application. Today we'll be talking about Node.js to the extreme, stream to scale. So, Gadi, welcome. How are you?
Hey, I'm good. How are you?
Very, very well. There is just a small, just a short delay in the sound, but I hope it will not gonna impact us. Tell us a few words about yourself. Where are you from?
Yeah, I'm from Israel, just like Karim. Actually, I know Karim. And I'm been a software developer for more than 7 years. And yeah, my past experience is at .NET and C#. And in the past 2 years, I'm developing in Node.js and JavaScript. And I really loved it. I really loved the whole ecosystem of Node. And that's it.
Perfect. Look, we're starting now your session. At the end of the session, I'll connect just for a few minutes, and I will show 5 minutes left, then 2 minutes left, and then 1 minute left. We are still on schedule. We just took 5 more minutes because Karin wasn't able to attend the Q&A session, and that was it. But we are still on a good schedule, and the audience is there already. They are already cheering you. So go ahead. Good luck.
Okay, thank you very much. So, really happy to be here and talk in Geekle Global Summit. And this is taking Node.js to the extreme. My name is Gadi. A little bit about myself. I'm married to Hila. We have a son named Ori and a dog named Angie, as you can see in those pictures. I'm a senior full stack developer at a company that's called WalkMe. I love to speak and write about technology, just like I'm doing here today. And feel free to follow me on Twitter when I tweet mainly about JavaScript, Node.js, and everything that is interesting and new in development. So what we're going to talk about in the next 30 minutes. And I'll first show you my big data challenge that I had in WalkMe. And then I'll do a quick introduction about Node.js Streams. Then I will go over my challenge solution using Streams. Then I'm going to show you some tips of using Streams. And in the last part, I will talk about async iterators and async generators and how they are integrating with Streams. So before I start, a quick story. So I have when I had the big data challenge, and I explored a few solutions, and one of those solutions was using Streams. I had to admit that I was a bit afraid of using Streams, because let's face it, Streams has a bad reputation. People are saying that Streams are hard, we're very advanced, they don't trust Streams in production, and I think the main reason for it is because Streams are available in Node since the first version of Node. And back then, the API wasn't really baked as it is today. Even in the social media, you can find tweets like this. This is Dan Abramov, the creator of Redux. He's saying that he's afraid of Streams. So when I started reading about Streams and learning about Streams, I saw that Streams are not that hard. And actually, the API since Node version 10, it's really, really easy. And my goal in this talk is that your next tweet will be, this is why you love Streams. So, okay. So let's understand the issue that I had in WalkMe. In order to do so, I need to present you a quick architecture overview. So in WalkMe, we have a website, a platform that we show all sorts of data and analytics about our user usage of WalkMe. And a user can choose to export this data to a CSV file to his email. And when a user clicks on exports, that's when we are sending a message to this reports queue. And in each message, there is a generated SQL query according to the user preference and filters. We got the consumers. You can see there is more than one consumer here. Those consumers are subscribing to this queue, and there are Node.js applications, and their job is to take those messages, take these SQL queries, and query our database, which is called Athena. Athena is a managed service in AWS, which wraps analytical DB that's called PrestoDB. Presto is developed by Facebook. And what Athena does is takes the results of the SQL query of Presto, convert it to CSV file, save it to S3, and it returns the S3 URL to the consumer. Now the consumer can send an email to the customer that requested this data. So this feature worked well in production and everything was okay, until suddenly we started to grow more and more. We started to have more customers, and more customers use this feature. That means that more and more messages were in this queue, and we didn't have problem scaling those number of consumers in order to cope with those messages. We started to have a problem in this area, in the Athena area. We started to have a bottleneck here. The main reason for it is because Athena is a managed service in AWS, and it has a limitation. It only supports 5 concurrent queries. And our queries are pretty complex, and since it's an analytical DB, each query can take a few minutes. So that's caused the bottleneck. We also have another problem here, because as we grow more and more, our data became bigger, and we needed more compute power in the nodes of the cluster, and you can't really modify them in Athena. So in order to solve those two problems, we decided to manage a Presto cluster on our own. So now we don't have the concurrent limitation problem that I explained before, and we can add more compute power by modifying our nodes in the cluster. So now the flows goes like this. The report sends an SQL query to Presto. Presto will now return the data as JSON. And now it's on our consumer responsibility to change the data from JSON to CSV file, save it to S3, get the S3 URL, and then send an email just like before. So this is what we needed to implement. This is the challenge. And a naive solution to it will be something like in-memory solution like this. There's a function for it called export events, which gets the SQL query. Get all events will get the events from the DB as JSON. And now we have to convert them from JSON to CSV. And you can see the second line here. This line is synchronous, and you really want to avoid it when you're using a Node.js, because Node.js is single-threaded. And if this operation will take time, we will block the event loop, and we want to avoid it. In the third line, I'm writing the CSV file to S3. So let's see a quick demo of this code. Let me go to my VS Code, and I have a file called, let me make it bigger so you can see it. So this is the 3 lines that I showed you. And actually, I'm not calling a DB here. I'm simulating the database results by reading from a file. And I have a small file.json, which is 8 megabytes of JSON. So let me run this code real quickly. And in the end, I'm printing the memory usage of this script. So it used 86 megabytes of memory. This is quite a lot, right? Because I told you that small file.json is only 8 megabytes. What will happen if I'll take a bigger file? Sorry, bug, yeah. A big file.json is 400 megabytes of JSON. Let me run it. And I'm using Node 14, which is the latest version of Node. And the default value of the memory in Node process is 2 gigabytes. So let's wait a few seconds here and we'll see what will happen. Okay, we got an error, a really big one. You can see it's V8. It's the engine of Node.js. And it's a fatal error, you can see here. And it's saying that JavaScript hit out of memory. So if you get this error, your process will crash and there's nothing you can do about it. No try and catch will help you. So you really don't want to get to this point. And you can do something like this. You can add a flag called max old space size, which will increase the memory of the process from 2 gigabytes, that is the default one, to in here it's 4 gigabytes. And you can see it fixed this specific issue here. The script now uses 2.6 gigabytes of memory. But this solution doesn't really scale, right? Because if you use more and more data and our data will get bigger and bigger, we need to increase the memory each time. And we want to avoid it. We don't want our services to have large amount of memory. We want, if we're working with architecture, microservices architecture, we want our services to be slim. And also, like I told you about this synchronous operation here, if the data will become bigger and bigger, it will take more and more time to process and block the event loop. So we really want to avoid these kind of things. So before I show you the solution using streams, let's understand first what are streams. Where the basic definition of streams are interfacing for reading and writing data. Stream can be piped together. Just like in Linux, we got one command, there's the pipe, the line, and the second command, then the output of the first command will pass to the input of the second command. Streams work the same. You can pipe streams together in a pipeline, and the data will flow in the pipeline by chunks. Node.js Streams extends event emitter. It means that they're emitting and subscribing events in order to communicate with each other. In order to pass data in the pipeline, they will emit and subscribe the data event. There are all sorts of events. You got close event, you got finish event, you got error event, etc. And there are also 4 types of streams. The first type is readable type. Readable will always be the first stream in the pipeline. It's responsible for reading data from some sort of source. It could be a file, it could be a DB, it could be an API. Writable stream will always be the last stream in the pipeline. It's responsible for writing data. It could be, again, a DB file, even a std out. Duplex is readable and writable, but the readable and the writable are independent with each other. A good example for duplex is HTTP sockets, when you can write to socket and read from socket independently. Transform stream extends duplex, which means that he is readable and writable also. But this time, the readable and the writable are dependent with each other. So you can think of transform stream as it reads data, it transform it, modify it, do whatever you want with it, and then write this data forward in the pipeline. So this is the solution using streams. Here I'm retaining a promise, and the first line is read all events. The that will create a readable stream for me from the database. The second line is JSON to CSV, which will return a transform stream. And the third line is write all events with a CSV file. It will create a writable stream. So after these 3 lines, I'm basically just initializing 3 streams objects. Nothing is done here. Only when I'm calling pipe and piping them together in this line, it will signal the readable stream to start read data and start moving data in the pipeline. Since I want to return promise, I'm subscribing to the finish event of the last stream in the pipeline, which is the writable stream. And when it will be triggered, I know that the pipeline is done and I can resolve the promise. So now that we saw the 2 solutions, let's compare them. It's a bit spoiler, I know, but you can probably guess the results. Okay, so let's go to streams.js and run it. This is the code that I showed you. And I'm doing here the same thing as I did before. I'm using now big file.json, which is 400 megabytes, and printing the memory usage in the end. And let's wait a few seconds and see what will happen here. I'm using create read stream and create write stream from the file system. And the transform stream is from JSON to CSV module. So here, I used only 21 megabytes comparing to the 2.6 with the in-memory solution. So this is far, far less memory usage. And what's really impressive about this solution, more impressive than the low memory usage, is that this solution can scale, right? Because here I used only 400 megabytes of data. In WalkMe, we use gigabytes of data and even tens of gigabytes of data, and we still will have the same memory usage. You can even have terabytes of data, and it will have the same memory usage. And I have to admit that I didn't know that Node.js and Streams have that kind of power. I always thought that in order to cope with big data, you need some sort of big data solutions, clusters of Hadoop and Spark. But it turns out that a single process of Node.js and Stream can handle this kind of data. So pretty cool. So now that you saw that streams are awesome and powerful, you probably ask yourself, can we create a stream? The answer, like that man said, yes, we can. So let's see an example of readable stream. And this is the API since Node 10. Here we are requiring stream module, which is a built-in model in Node.js, taking the readable from it and doing new readable, and we have to implement a read method. This read function gets a size parameter, which indicates the size that you want to read each time you're fetching data. We're not going to use it here because here in this example, I'm creating the data on my own. I have here hello Geekle string. I'm using the spread operator in order to convert it to array of characters. So I'm iterating on each character and doing this dot push on each character, which will pass this data to the next stream in the pipeline. When I'm done iterating over this whole string, I'm doing this dot push now, and it will signal the next stream in the pipeline that I'm done reading the data. Here's an example of transform stream, again, requiring from the stream model, doing new transform. Then I have to implement the function called transform, which will get chunk, encoding, and callback. Chunk is the data from the previous stream, and I will call callback when I'm done transforming the data and I want to write it to the next stream in the pipeline. So here callback, the first parameter is an error. I will pass here null because I don't have error. Chunk is a buffer type, so I'm doing toString and then doing two uppercase because this is the transformation that I want to do on each character. So when we're piping it all together, the readable stream that I showed you, the transform stream, And when we pipe it to process std out, which is a built-in writable stream in Node.js, we will print to the screen, hello Geekle, all capital letters. So this is pretty basic and pretty simple example, but it's just to demonstrate you how easy it is to work with streams and create streams on your own. Let's see some tips of using streams. So the first tip is error handling, and this is a true story from production. So I had this code in production. This is the solution using streams that I showed you, and this code can break, right? Because we are reading data from the database, we are transforming data, we are writing files to S3. So you can have a communication problem, DB problems, etc. So in order to protect it, I did what every developer will do. I will wrap it with try and catch, right? But it turns out that this isn't enough in streams because I got unhandled promise rejections in production. It turns out that in order to solve it, you need to subscribe to the error event on each stream in the pipeline. So if I get now an error in those streams, it will trigger the error event, and then I can reject this promise, and then I won't get the unhandled promise rejections. But there's something messy here, yes, but because this a duplication of code. I have to do the on error on each stream in the pipeline, right? And we as a developer, we don't want to duplicate code. So you can improve it by changing from the pipe method to the pipeline API, which is built in Streams module. And the pipeline API gets as parameters the streams in the pipeline, and the last parameter is a callback. So even if I had an error in the first stream, the error will propagate to the last parameter, and if I'll get an error, I can reject the promise. So I can avoid the duplication of error here, and also I can remove the onFinish event here, because when the pipeline is finished, it will call also the callback, and then I can, if I don't have any error, I can resolve the promise. And you can even improve it even more by calling util promisify, which is built in also in Node.js, and it will convert the pipeline API from using callbacks to using promises and create pipeline async. Now you can just await on the pipeline async, and you're good. You don't have callbacks here, and you can wrap it with try and catch, and then you will be able to catch the error. Back pressure is another important topic. Back pressure is basically when you have two streams that are connected to each other. If the first stream produces more data than the second stream can handle, it can cause a back pressure, and it can cause you to use more and more memory in your process, which can eventually make you the error that I showed before, the JavaScript heap out of memory. And you really want to avoid it, right? So don't do this. Don't subscribe to the data event, and from this data event, write to the next stream in the pipeline. If you do this, you can potentially have back pressure problem. What you need to do is call the pipe and the pipeline API that I showed you before in my examples. And luckily for us, the core team of Node.js took care of balancing the back pressure in those functions. And so basically, you just need to call them and you'll be fine. Object mode option is another useful thing in streams. The default, it's an option that you can pass to streams, and the default value of it, if you don't pass it, is false, which means that you can read and write to streams only strings and buffers. So if you work in here in this example with object, you need to stringify it in order to write it. And again, you need to parse it in the transform stream here in order to modify it and stringify it back back again.
5 minutes left.
Thanks. So if you use object, I really suggest using ObjectMode true here. Then you can work with object here, like I'm doing here, and the transform stream. You can transform the data, and you can avoid the stringify and parse each time. highWaterMark options is another important option in streams. It indicates the size that you can read and write in each chunk of stream. The default value of it is 16Ks, and you can really play with this number in order to optimize your streams. Basically it's a trade-off between the speed that you will read and write the stream and the memory usage that you will have. So generator functions. Let's talk about generator functions. Generator functions create iterable objects. I will explain to you in a second what is it. This is an example of generator function. Well, generator function has an asterisk, as you can see, and a yield keyword. So in this example, I have start and end index, and I'm just do a for loop from the start to the end and yielding each number. The usage of a generator function is like this. When I'm calling it, it will create a generate object. And this generate object is an iterable object, which means that he implements the Iterator protocol, which basically means that it has a next method, and the next method will return a value, object with a value. So if I'm calling it in the first time, it will print 1, the second time will print 2, the third time will print 3. More easy usage for it is use the for off loop of it, and then you can iterate over it, and you don't need to call the next and the value. But why I'm talking about generator functions, because you can create readable stream from generator functions. You can see this is my previous example of Hello Geekle, and I'm creating a generator function, and I'm yielding each character. I can use the readable from the stream module here and do readable from the generator function, and then it will create a readable stream for me. Then I can pipe it to the stdout, just like here. And you can compare it to the previous example that I showed you, and I think this syntax is much more elegant and much more easy. You don't have to implement read, and you don't have to do this dot push with null in order to indicate that you are done reading. Just for loop with yield. Generator function can be async also, and that means that they can create async iterable objects. So again, the same example, only this time I'm using async and await here, and I'm waiting on the promise to set timeout for 1 second and then yielding the next number. If I'm calling it, it will create an async iterable object, which means, again, it implements the async iterator protocol, which is the same as iterator protocol, but the only difference is now the next method will return a promise. So I need to await on it. And every time I'm calling next, I will wait 1 second and yield the number. A more easy usage for it is use it in for loop, and you can see this is a new syntax for await off, and you can iterate over the async generator function, and it will print 1, 2, and 3 and wait 1 second each time. So readable streams are async iterable object, which means that you can do the for await loop that I showed you on streams. Very useful if you want to process the chunks or do whatever you want with the chunk. You can do the for await loop of readable streams. So you can combine those two together. This is an example of async generator function that use for await off loop over stream and then yielding the value. What's really cool about it is that the pipeline API supports generator. And this is brand new in Node 14. And check this syntax out. I'm using the pipeline API, and you can see it supports streams, right? But this time it can support a generator function. This is anonymous generator function I'm yielding each character of hello Geekle. And this is really cool. I don't have to do the readable from in order to convert the generator to stream. I can just work with generator functions. And the second argument here is async generator function with the for wait of loop. And then I'm doing to uppercase to each character, just like I did before. The third parameter is a process std out, which will print the characters all capital. So this is brand new syntax. It's really, really cool in my opinion. Really reminds me of how you can combine middlewares with Express. So I find it very useful. So to sum things up, don't afraid to take Node.js to the extreme. That's just like I showed you here. A simple Node.js process and stream can handle really, really big data. Streams API is easy, just like I showed you here. You can create streams on your own. And the core team of Node.js keeps improving the API more and more, just like I show you with the Node 14 example now. Also, the documentation is really good. Follow the best practices that I showed you here in order to work with streams properly, and you'll be fine. That's it. If you have any questions or you want to contact me or comments, feel free to do so. This is how you can do it. And thank you very much.
Thank you, Gadi. That was amazing. And again, I see a lot of discussions here, so it looks like you're gonna get a lot of questions during the Q&A session. Yeah, people are supporting you. It looks like you're quite famous in the community.
Wow, I didn't know it.
And the examples are just amazing. People are getting a lot of fun. Yay! Yeah, there's a lot of thanks in the chat. All right. We appreciate your time here. Thank you. And tell us, please, is that your first online conference, right?
Yeah, it's my first online conference. Yeah.
That's good. Everyone today here, at least at the junior track, have their first experience. And yeah, we realized that this is a quite new format, actually. And even though we're getting some small glitches and so on, we are getting fixed them ASAP. And well, it's always better to do something than nothing, right?
Yeah.
That's true. Thank you very much. We will get back in a few minutes to the next